Okay, here is the second question for solving second law and friction questions. Everybody should be expected to solve 2A and 2B. 2C, I think for this year, because of time constraints, some students are going to have problems with 2C. I'm not going to spend a lot of time on it. Well, I'm going to go over it. If you find this to be a little bit beyond where you're at this year, then that's just the way things are because of our shortened year. But let's go through A and B. So first of all, I just want to be really clear, that's a 1 kilogram object. This is a 4 kilogram object. I'm going to call this M4 and M1. We have two objects, there's two masses, so let's try and be clear on what those things are. First thing it asks is draw a force diagram for the block on the table. So M4, normal force up, table on mass or block, earth on block, and this block is not accelerating up or down, so those forces are balanced. There's force of tension, what we can say it's from, not just rope on block, and there's probably some friction here, table on block. Alright, so that's cool. I'm also going to do a force diagram for mass M1. So that's FG. I'm going to call it FG1, earth on M1, and I'll call this force of tension, rope on M1. Okay, so we have two force diagrams. Next it says, what would be the minimum value of the coefficient of static friction in order for the block to remain motionless? So if this is motionless, that means that force of friction equals force of tension, because that means it would be balanced. That would be balanced with that. That's if it's motionless. Alright, so that tells us a little bit of information, but there's other stuff we know too, and it kind of works like this. If you know FG1, and you do, FG1 is M1 times G, so that's 1 kilogram times 9.8 meters per second squared, that's 9.8 newtons. If you know FG1, then you know FT, because this thing's not, if that block's not moving, this block's not moving. So those two forces would be balanced. So if you know FG1, you know FT, that's the tension. And the tension of this rope is the same as the tension on that rope, which is that force. And that tension is balanced with the force of friction. So we actually know all these things. Force of friction is the force of tension, which is Fg1, which is 9.8 newtons. And we want to know what the coefficient of static friction is. So we're going to be using this formula. Force of friction is mu s Fn. Fn is equal and opposite to Fg, so we could go, well, Fg is mg, which is 4 kilograms times 9.8 meters per second squared. So Fg is, where's my calculator, 39.2. And that's equal to Fn. So the coefficient of static friction is force of friction divided by Fn, which is 9.8 newtons divided by 39.2 newtons, and that should be 0.25. Okay, done. So everybody should be able to do that. The next question is trickier. I'll go through it as well, but it says if the coefficient of kinetic friction mu k is 0.25 to 0, what is the acceleration of the block? Well, the way we can do that one is, it's kind of like a lot of math. There's an easier way to do it as well. But I shall show the easier way to do it. And the easier way for that is to treat these MET blocks as one system. So there's M1, there's that was M4, this is M1, and it's being pulled with a force Fg1. And on M4 there's a force of friction. In here is some tension, but those tensions are equal and opposite. So if we think of this as just one big object, think of it as mass total, or MT, which is M4 plus M1. So now we have a much simpler problem to work with. We have one object that's being pulled one way with the force of Fg1. So the only force that's pulling this whole system down is that force there, force of gravity acting on that 1 kilogram mass. And there's a force acting in the opposite direction, which is the force of friction, which is the force of friction acting on this block. So treat the whole thing as a system, and we can say that Fnet is equal to Fg1 minus force of friction. And we also know that acceleration is Fnet divided by the total mass. Fnet hasn't changed, that's 9.8 newtons. And force of friction is mu k times Fn. So they told us mu k. Fn hasn't changed, it is still 39.2. So that's 1.96. So that's the total force acting on that system of objects. So the acceleration is 1.96 newtons. The total mass is 4 kilograms plus 1 kilogram. So we'll divide this by 5. So the acceleration is 0.39 meters per second squared. And again, we can treat that as a system. You can treat those two masses as one big mass because they're basically held together with a rigid line. So as this one moves down at the same rate because they're attached. Alright.